Welcome back to Physics for the Real World. Well, when last we talked, I left you with a little puzzle. You recall I described the old system of the world. That is the system of the world that had the Earth in the center, and then surrounding the Earth was a layer of water, and surrounding the water was a layer of air, and then above that was a layer of the fires. And in this world, not only was there a separation into different elements, these things were called the earth, water, air, etc., were called the elements. Not only was there separation in different elements, but there were different rules. There was a different physics that applied as you went up. And a typical example of that was that on the earth, perpetual motion was impossible. But up here, in the fiery realm, the realm of the sun, moon, and stars, perpetual motion was required. Nothing up here could stand still, while nothing down here could remain in perpetual motion. So there was different layers of physics. And of course that seemed quite okay because people realized that there are different rules that the people down here live under than the people up here. There's different realms of rules. For example, you know that rulers live by different rules than the ruled. You and I stand in line to get our driver's license renewed. Have you ever seen the mayor standing in that line to get his license renewed, or the governor, or the vice president? Of course not. They live by different rules. And in those days, long ago, it was thought that there would be different physics, too, up here than down here. But I left you with a little puzzle last time. And the little puzzle was this. True, there's a fire up here. It's the hot things up here. But down in the very center of the Earth, of course, if you go inside the Earth, you also find that there's some fire in a little realm down inside the Earth. I won't draw it in there, but you all know that it's in there. And of course, that was something that was out of the natural order. The fires should be all up here. There shouldn't be any fire left inside the center of the Earth. How are you to explain that? Well, that's something unnatural. And that was, as people saw it in those days, the work of the devil. The devil was someone who originally was up here with God in the realm of fire, and then had a falling out with God and has got himself as far away as he could from God, which I suppose was down in the center of the earth. But being that he originally came from this realm, he brought some of this characteristic with him, and that's how come there was some fire in the center of the earth. That was something out of God's plan, something contrary to the overall scheme, and you could see that right away by seeing that it was a bit of the fire trapped inside of the earth, where it certainly did not belong. Okay, so much for that. That was the view of the world that people had in the days of the Greeks and before the Greeks, in the days of the Egyptians, in the days of the Greeks and the Romans in the Middle Ages, right up even until the time of Columbus. That's the view of the world that people had. And then I told you that about the time of Columbus, along came a new idea, and that new idea was that the sun was at the center of the universe, and the planets went around the sun, and that the Earth was one of the planets, and that it went around the sun, and the other planets went around the sun, and then surrounding that were the stars out beyond that. Now, I want to show you that a few things about how new was that idea. You say, well, gee, that's not a new idea. Copernicus' idea that the sun is in the center of the solar system and the Earth is a planet, that's now an ancient idea. It's certainly not a new idea anymore. But I want to show you historically how new an idea that is. And I'm going to put on the blackboard here a little picture of the history of the world according to Epstein. Here's Epstein's fast history of the world. And let's start let's start the history of the world back at 1000. Well, first of all, let me draw a line. The physicist's history of the world has to have a line. We'll start back here at 1000 BC. What happened around 1000 BC? Well, there were probably still some Egyptians around. They might have been building some of the last pyramids around 1000 BC. So we can still say we're back in the days of the Egyptians. And I'll put a pyramid here. 1000 BC. Now let's come up a little bit. Let's come up to just 500, a leap of 500 years BC. Of course, that's a big leap. 500 years, because a generation is maybe 20 years, so 100 years conceivably you can get in 5 generations, 5 generations in 100 years, and for 500 years you can get 25 generations of people between here and here, 25 generations. But you come up, what happened about 500 BC? Well, that's about the time that the Greek Pythagoras lived, roughly. And that's the guy that worked out that famous theorem that if you have a triangle and you take a square on that leg and a square on that leg, the sum of the 2 squares will add up to the square on that leg. That's 500 BC. Well, let's go up to the year 0. Up here is about the year 0. What happened around the year 0? Well, that was the time of Julius Caesar, isn't that right? So here's Julius Caesar, and we'll draw his little, the crown of Julius Caesar, which is what, the wreath, was it olive leaves or something like that. And then we come up beyond Julius Caesar, let's come up another 500 years. Now we're 500 AD. What happened around 500 AD? That was about the end of the fall of the Roman Empire. And so here I'll draw a plaque like the Romans used to always make these ornamental things, and then I'll break it. See, it's broken there, and that's the ornamentation, the Roman ornamentation being broken down and cracked off by the barbarians or lack of maintenance. Okay, let's come up another 500 years. Another 500 years. We're up to the year 1000. 1000 AD. What happened around the year 1000 AD? Well, that's about the last time England was actually invaded by foreigners. That's the time of the Norman invasion. The Norman were Frenchmen that came over to England, and in fact, as an everlasting consequence of that, we have 2 words for a lot of things in English, like pig, and then there is pork, or there's cow meat and beef. You see, there's a lot of times in English, sheep and mutton. There's a French word and an English word, isn't that right? In fancy restaurants, you use the French word, and then out on the farm, you use the English word. Well, that's because the French came over in the year 1000 to England, and they used fancy French words that have stuck around ever since. That's the French invasion of England. Okay, well then, let's go up to the year 1500, another 500-year leap. What happened about that time? Well, that was the time of Christopher Columbus, isn't that right? That's just about the time Christopher Columbus sailed and discovered the New World. Drew a few of his ships there on the water, and that's Christopher Columbus's ship. And finally, we'll get up to the year 2000. 2000 AD. Well, what's that? What happened in the year 2000 AD? That's just about now, isn't that right? Now, that's 2000 AD. Okay, good enough. Now, here's the Epstein short history of the world concluded. Now I want to go back and talk about Copernicus and the new idea. The old idea of the world, the idea that I've talked about with the Earth in the center, started out heaven knows when, probably way back before the time of the Egyptians, maybe in the time of the Babylonians. And that idea that the Earth was in the center of the world, the Earth-centered world continued up all all through here, through here, through here, through here, until just about the same time as Columbus discovered the New World. And then that's how long it extended. Of course, some people believe it even to this day. But at this time came the new idea, came the idea that the earth might not be in the center of the world, it might be the sun that was in the center of the world and the earth just going around. Came Copernicus's idea. The idea started here, and then it continues on until the present time, which is now. The point I want to make is that this new idea of the world that we have, that you think is old, is actually, we've just had it for a short time. Look at how it's just a baby as far as ideas go, compared to this other idea of the earth, air, fire, and water, which is so much of a longer history. So this idea that the earth is not in the center of the world is a very new idea. Okay. Now, when this idea first appeared, and Copernicus made this idea, actually what happened, you might think that people would get mad about the new idea. People have a feeling that new ideas are always unwelcome, and new ideas probably always are unwelcome. But when Copernicus came out with his idea was so far out, so outlandish, so wild that no one, or when I say no one, of course I really mean very few people, took it seriously. It was regarded by most knowledgeable people as the ravings of a street person or the ravings of a drunk. It was not to be taken seriously. It was too far out. No one ever got mad at Copernicus for what he said. It's interesting. I'll tell you a little bit about Copernicus when we get on to it. But no one ever got mad at him because no one took the idea that seriously, except for a very small group of people. No one took the idea seriously. Why didn't they take the idea seriously? What's wrong with Copernicus's idea that the Earth is in the center of the world? Not that the sun is in the center of the world and that the Earth moves around it. What's wrong with that idea? Well, I'll tell you what's wrong with it. First of all, as I said before, all up to this time, people took astrology very seriously. And Copernicus's theory left no room for astrology. Because the planets had to be something special. If you were going to have astrology, the planets there had to be something special about the planets. But if the Earth was just a planet, like all the other planets, there was nothing special about the Earth. So how could the Earth? How could there be astrology? And you could see now, if the Earth was just like the other planets, and the Earth somehow moved around the sun, then the Earth would have to be like the other planets, and it would have to shine in the dark. Now, does the Earth shine in the dark? Certainly the Earth doesn't shine in the dark, but planets, being up in the fiery sphere, they shine in the dark. So you can't think that the Earth is a planet, like the other planets. Secondly, let's go on and think of some more things. What is the Earth? The Earth is earthy, and it's not fiery like the other planets are. It's not made of the same kind of stuff. On the Earth, there is no perpetual motion. But among things on the Earth, if you set something to moving on the Earth, like I set this to moving, it comes to stop very quickly. That's how things work on the Earth. But if we're up among the planets, it's different. Once a planet will move and move and move. It'll move for all historical time. In fact, the planets have been moving continuously for this whole sweep of time here. Even up until now, they've been moving. And so you can see that there's something different about them. There's nothing on the Earth that moves like that. So you can see that there's entirely different sort of thing. On the Earth, there is nothing that goes on. Not only is motion on the Earth, not only is there no perpetual motion on the Earth, but also on the Earth, nothing lasts. Everything on the Earth gets torn down. No tree lasts forever. No animal lives forever. No person lives forever. Every building eventually crumbles. Even the mountains wear down gradually. Nothing on the Earth lasts. But if you look up in the sky, everything in the sky stays the same from generation to generation to generation to generation. Everything in the sky. The constellations stay the constellations. The stars don't get brighter and they don't get dimmer. The sun and the moon, every full moon is just as bright as every other full moon. The moon doesn't gradually shrink away. It stays the same. And there's no way in the world that you can say those things up there are the same as the things down here. They're basically deep down inside very different. Also, up there is the realm of the gods. Obviously, up there was the belief in those days that the things up there were controlling the works down here on the Earth. Now, if the Earth is like a planet and the planets are like the Earth, then there should be gods here controlling the planets up there. Have you ever seen any gods down here? I ask you. Of course there's no gods down here. So, how could we be on the same footing as the planets? Ridiculous. Okay. So you can see the Earth is not like a planet, and you can also see the planets are not earthy. Because if the planets were earthy, they wouldn't shine in the dark. If the planets were earthy, they'd be heavy. And if they were heavy, two things would happen. The planets would stop moving. Not only would they stop moving, but they would fall. The planets neither stop moving nor do they fall, so the planets could not be like the Earth. Just as the Earth could not be like the planets could not be like the Earth. So what I've tried to show is that every characteristic that you ascribe to a planet, the Earth cannot have that characteristic. And every conceivable characteristic that you ascribe to the Earth, a planet cannot have. And so it is inconceivable to think of the Earth as being like a planet, and it is equally inconceivable to think of the planets as being like the Earth. Now, let's go to the main issue. The idea that Copernicus has, if the Earth is like a planet, is that the Earth moves around the sun. The Earth cannot move. Now, first of all, it's a heavy thing. It's the heaviest thing in the world. So it cannot move. But let's suppose for some reason some devil set the Earth moving. Then the Earth, being the heaviest thing in the world, would come to a stop. Even if it were to be in motion by the action of some devil, it would stop moving. Now, that's by reason. By reason, you can reason out that it's logically impossible for the Earth to move. But suppose you don't want to use your head. You're not so bright as to want to think it out. You can just tell by your senses that the Earth is not moving. Because if the Earth was moving, you would feel it. You could tell. Just like you can tell when you're walking that you're moving. You can tell which way you're moving. When you're on a horse, you can tell which way you're moving. If you're in a wagon, you can tell which way you're moving. If you're on board ship, you can tell which way you're moving. Any time that you're moving, you can tell. Now on the Earth, can you tell which way you're moving? As I've pointed out right here, you cannot tell. I cannot tell which way I'm moving. And if I go outside, I still can't tell which way I'm moving. But I'd like to do a demonstration. And here is a demonstration. If you suppose that the Earth is moving, and in those days, in the days of Copernicus, people did have an idea what the size of the Earth was. They had a pretty darn good idea of what the size of the Earth was. So what's the diameter of the Earth? This is the Earth. The diameter of the Earth was known, even by the ancient people, to be approximately 8,000 miles through the center of the Earth. 8,000. Okay. Okay. Now, if we want to find the circumference of the Earth, that's the distance around the Earth, you take the diameter and multiply it by pi, the magic number pi. Now, what is pi? Pi is approximately 3. In fact, it says so at several different places in the Bible that the value of pi is 3, so we'll use the biblical value of pi. So the circumference of the Earth is equal to 8,000 miles times 3, which comes up to 24,000 miles. So the circumference of the Earth has to be approximately 24,000 miles around the equator. More or less ancient knowledge. Now, how long does it take the Earth to turn? According to Copernicus's theory. Let's just go along with Copernicus. By the way, I should tell you that Copernicus's idea, not about the Earth moving, is particularly crazy. It's doubly crazy because Copernicus says two things about the Earth. He says one thing, that the Earth walks in a circle around the sun. The Earth goes in a great circle around the sun, and it takes a year to walk in this great circle around the sun. But at the same time that it's going in this great circle around the sun, according to Copernicus, the Earth is turning around itself like this every 24 hours. Every 24 hours. In other words, what Copernicus said, instead of the heavens going around the Earth, the heavens are standing still, and the Earth is sitting there spinning like this once every 24 hours, which means that if you were on the equator, you'd have to go all the way around and come back to where you were every 24 hours. And how far would you have to go every 24 hours? You'd have to go 24,000 miles. If you go 24,000 miles and you go do it in one day, which means 24 hours, how fast are you going? Well, you'd have to divide this by 24 hours. If you divide that by 24 hours, 24,000 miles divided by 24 hours means you're going 1,000 miles per hour. A person riding on the equator of the Earth is going at 1,000 miles an hour. If you were going 1,000 miles an hour, you'd surely know it. It's absolutely crazy. I'll show you a way that you would know it. If the Earth is going at 1,000 miles an hour, then of course the floor is going at 1,000 miles an hour, and my foot is going at 1,000 miles an hour. Now, I have a piece of chalk in my hand, and I'm going to drop this piece of chalk right over my toe. I'm not going to do the experiment because you know what the outcome will be. It would be a waste of a piece of chalk. I'm not going to do it. But let me just describe it. You can do it yourself if you need to. I don't think you need to. What happens if you drop a piece of chalk directly above your toe, very carefully? Well, every kid knows that when you drop a piece of chalk directly above your toe, it's going to hit your toe. Now, if the toe was attached to the floor, which it is, and moving with the floor, and the floor was moving 1,000 miles an hour, do you think by the time the chalk got down from my nose and fell all the way down to the floor, would my toe still be there? No, my toe would be out someplace, far away. If it was going 1,000 miles an hour, and the chalk wouldn't hit my toe. But every time you drop the chalk, it hits your toe, which shows that the toe is standing still and not going anyplace, but the toe is attached to the floor, is attached to the Earth. So the Earth could not be moving. Absolutely. The whole idea is ridiculous from top to bottom. Copernicus's whole idea is ridiculous. Let me show you some more of this spinning thing. Let me show you some. Let's suppose the Earth was spinning at 1,000 miles an hour. Well, you know what happens. If your dog is wet and your dog spins, what happens? All the water goes flying off, isn't that right? Most of the surface of the Earth is covered by oceans. If the Earth were spinning, the oceans would be flung off it. The people would be flung off it. The houses, the buildings, everything would be flung off the Earth. There's no way in the world that the Earth could possibly be spinning. without throwing everything off. Now, I want to tell you something else about Copernicus' idea, another point of ridiculousness in his idea. In the old idea, the ancient idea, everything went around the earth. The sun, the moon, the stars, the planets, everything was consistent. It was a beautiful logical structure. Now, according to Copernicus, you would think, well, everything is going to go around the sun, crazy as that is. And you say, the planet Mercury will go around, the planet Venus will go around, the planet Earth will go around. We'll just pretend that it goes around. Of course, it really doesn't. And Jupiter and Saturn, they all go around the sun. Except, what about the moon? No. The moon doesn't go around the sun. According to Copernicus, the moon goes around the earth. There's that swan still. He sticks to that ancient idea. The moon goes around the earth. You see, the theory doesn't have the beautiful logic. It's not one smooth idea like the previous idea. It has to have this exception. Now, also I want to show you the ridiculousness of this. Supposing the moon, the earth, suppose the earth is in motion around the sun. So the earth is moving around the sun. Then the moon is trying to move around the earth at the same time that the earth is trying to move around the sun. Have you ever had your dog try to run around you on a leash at the same time you're running around something else? There will be a great entanglement. In fact, there is a principle that a center of motion cannot itself be in motion, because the center of motion must be the dead center. So if the moon is moving around the earth, then the center of the earth must be the dead center, and that center can certainly not be in motion around the sun. A center of motion cannot be itself in motion. So the explanation of the moon displays the internal inconsistency in Copernicus's crazy logic. But finally, I would like to tell you the ultimate explanation. The ultimate explanation to show the illogicalness and the error of Copernicus's idea. And that is this. If you will look out into the world, and by the world I mean the world of the distant things, say the world of the stars, and you will imagine, let's pretend, of course it's not true, but let's pretend that the earth is moving around a circle. And here we'll put this thing to be in the center to be the sun. Let this be the sun. And first the earth is over on one side of the sun, and you would see the world in a certain way. And then finally you get over onto the other side of the sun. How long does it take you to get over onto the other side of the sun? It's 6 months later. Would the stars look the same when they're over on the other side? No. Now, if you're the stars looking at my face, does my face look the same? No, you see this side of my face now. And when I come over here to the other side of the sun 6 months later, this side of my face is hidden. And you see that side of my face. And similarly, when you look at the constellations, their appearance will change too. This is called parallax, and you know that things will look very different. In fact, if you're looking at a meter, like a meter on your car, or any kind of a meter, and there's a needle, and you move your head back and forth, you can make the needle, by putting your head in one place, make the car look like it's on empty, and by moving your head over to the other place, you make it look like it's on full. And so you would expect the appearance of the constellations would change if the Earth were moving around the sun. But everyone knows that the constellations, when you see them, do not change in the least. The Big Dipper always looks exactly like a Big Dipper. Cassiopeia always looks like Cassiopeia. The great square in Pegasus is always a great square, and the relative positions of the stars in that square don't change in the least. But if the Earth was moving in a circle in space, you would see the thing from different points of view, and they would have to change, but they don't change. So all these things go to show that the idea is to be dismissed and hardly to be taken as very serious. You don't have to know too much about science or logic or geometry to see that Copernicus' idea is a complete bust. Well, you might wonder where he got such a crazy idea, and I'm going to tell you now. I'm going to go into telling you a little bit about Copernicus himself, and you might, from that, maybe you can see how he might get such a crazy idea. Copernicus grew up in Poland. At the time that Poland was on the frontier of Europe. In Europe, civilization, of course, began in the Mediterranean world, and gradually it worked its way further and further north and further to the east. And at the time that Copernicus lived in Poland, Poland was the frontier of Europe. And what I mean by that is that the people in Poland were Christians. But if you went a little bit further to the east, you came into the region of the Slavs and wild people who were not yet Christianized. If you went into Poland in the time that Copernicus lived, people were still living in log cabins. Now, of course, if you visit Europe, you'll find very few houses made of wood. Most houses in Europe are made of brick and stone. Indeed, if you go even to the eastern United States, one of the things that people that live in California see mostly wooden houses. And it's always kind of surprising when you go back to New York and Boston and Washington, D.C. to look at the houses and see most of the houses there are made of stone. Of course, once the houses on the East Coast were made of logs, but they long ago they depleted their forests. So when you have your forest depleted, you certainly cannot live in a log cabin. But at the time that Copernicus lived, Poland was still forested. The forests were not depleted, and so people lived in log cabins. Copernicus must have been a smart kid. And he had an uncle who had some authority and some money. And his uncle said, listen, my smart nephew, I'm going to send him to school to get an education. And they sent him to school in Rome. That's very much like a kid that was born on the frontier. Suppose you had a kid that was born way out in Colorado or out in Texas way back in the days of the cowboys, and the kid was a smart kid. Well, you wouldn't send him to school out there. You'd send him back to Harvard University, isn't that right? Send him back east where there was civilization. And in the same way, they sent Copernicus out of Poland down to Rome to get himself educated. It must have been quite a trip down there. You couldn't take the train, you couldn't fly down, you couldn't take the bus. I wonder if he even had a horse to ride on. But somehow he got from Poland down to Rome. And down in Rome, he decided he had to, well, he not had to, he was obliged to educate himself. He went to the university down there. Incidentally, one of the things that happened at the very time that Copernicus was in Rome in the university is that Christopher Columbus made his first journey to the New World. Well, what did he study when he went there? Well, as I say, he's a kid that came from the frontier, and he had to study things that were worthwhile. And the two things that he studied, apparently, were law and medicine. I guess it's always a good thing to be able to know a little bit about the law so the lawyers can't take advantage of you, as they always will. Of course, now the lawyers got it so tight you can't even learn about law in an ordinary school. You have to be admitted to their own special school before they'll tell you anything. But in those days, I guess in the university, he could learn a little bit about law, and he could learn a little bit about medicine, whatever was known about medicine in those days, which is also something that would come in very handy. How worthwhile it would be now in a university to teach people, 1 year, some basic things about medicine, the most important things about medicine you could tell them for one semester. But of course the doctors won't allow that. But Copernicus went to school in Rome and learned those things. Now he did not study astronomy, but Copernicus was interested in astronomy, and he went they had astronomy classes. Of course, what they were teaching in those days was basically the old explanation of the world, but they taught in detail how it worked, exactly how the various circles of the sun and the circles of the moon worked, and how it went into some detail. But Copernicus went to the astronomy class, and he audited it. He didn't get any credit for it. He just said, well, I'm going to sit in the back row and listen to the astronomy class because it's an interesting subject. Of course, nobody will ever get a job as a scientist, but it makes a nice hobby, which is true even today. And he sit in the back of the class, and he listened. And that was it. That was the extent of his astronomy education, auditing the class. After he got through with his studies in Rome, he said, well, I'm through now. I'm going to go back to Poland, where I came from. That's also amazing because you think about people that come from a country to the United States to get educated. Suppose they come from a less developed country and they study in the United States, they study law or medicine, and finally they finish their college education. Well, 9 out of 10 of them have no intention of going back at all. They'll get a job in the United States, any excuse in the world not to go back. But Copernicus was a good man. He said, well, my uncle sent me down here, and now I've learned something. Now I'm going to go back. And so Copernicus went back to Poland, and he stayed there for the rest of his life. Now, if there were scientists around, any scientists or philosophers, they were down in Rome. And if he was interested at all in science, Poland was not the place to be. They weren't having any scientific meetings in Poland in those days. You can be sure of that. But he went back there, and he stayed there for the rest of his life. What did he do when he got back to Poland? Well, his uncle retired shortly after he got back to Poland, and he took over his uncle's job, the job that his uncle had. And what was that job? Well, in those days, the church did many things that governments do now. Little by little, of course, the churches once ran the schools and the courts and everything. And in those days, if you had an important document that you wanted to record, like a deed or a will or a birth certificate, you took it to a church office, and it was the church that recorded it. In other words, the church provided exactly the same function that a county clerk does now. If you have important documents like deeds and that sort of thing, you record them with the county clerk. And at that time, the church provided that service, and so that was his job. He was effectively the county clerk, which was his uncle's job, and he took it over. So that's how he made his living. And I can tell you one story about Copernicus. Who knows if it's true or not, but it's an often told story. Back at that time, just like today, they had a cafeteria for the government employees or the church employees. I suppose they figured if they all ate together at one place, they wouldn't spend so much time going out to lunch, and so they provided them bread and whatnot, and they all ate in a great room. Now, it would occasionally happen that the person who was bringing out the bread would drop the bread on the floor. And of course, since the person that was bringing out the bread also baked it and was probably had the concession for providing the bread, if he dropped the bread on the floor, he quickly picked up the bread and he served it. Now, also in those days, people brought the animals inside the house. There was a good reason. Up until very recently, people brought animals inside the house. Do you know the reason why people brought animals inside the house? The reason was to keep warm. If you had the animals in the house, you could stay warm. So you can be sure the same place where the people were eating, animals walked around. And Copernicus said that that's not a very good idea to pick up the bread off the floor and then serve it, because it makes the people sick, and then they have a lot of out time. They say they're sick and can't come to work, and we could avoid a lot of that if they just didn't serve the bread off the floor, because there's this new idea I heard about in Rome that there are germs on the floor, and the germs get on the bread. Then when you eat them, the germs get inside of the people, and that makes the people sick. Incidentally, the idea of germs what came up several times in history. Several times people got the idea that there was such a thing as germs, and then the idea went out of vogue. And then it came back and then went out of vogue again. So it went through, this was one of the cycles, one of the times apparently when people did believe in germs. So the boss man said, well, okay, this bread that hits the floor, you should not serve it. If you drop bread on the floor, don't serve it. So the order went out. Of course, the guy that was running the place, since he was being paid for the bread, and if it was out of his pocket, if he had to throw the bread away, he just picked up the bread and dusted it off a little more carefully, and he served it anyway. He didn't follow the instructions of the boss man. Copernicus realized that, and Copernicus then got an idea for how to stop the bread that fell on the floor from being served. He got the idea that you should take butter, and you should put butter on the bread. You should put butter on the top of the bread and on the bottom of it and all around the crust. And that way, if the bread hit the floor, you'd surely know it. And that was his idea. Well, of course, people also found that it tasted good that way with butter on it. And they also found probably it was easier just to leave the butter on the top so you could touch it on the bottom and on the sides. Who knows if the story is true or not, but it's a nice story. When did Copernicus do his astronomy? Copernicus did his astronomy when he went home at night. He was not paid to be an astronomer. He had no contract, no grant for research. Copernicus was an amateur astronomer. An amateur astronomer is one who does the study for love. I think amateur comes from amour, which is a fancy, probably French word for love, out of the love of the subject. And so here's the most famous astronomer in the world going home. And what did he do at home? He did, of course, in those days it wasn't even called astronomy. It was called natural astrology. By that time, the time of Copernicus, astrology had divided into two parts. There were two branches of astrology. One branch of astrology was called judicial astrology. Judicial astrology is, well, you know Jupiter is going to be here and Venus is going to be here and the sun and moon are going to be there and there. And what does that mean? What does that mean for you? How does that work out for you? Given that we know on 1 year from today where all the planets are going to be, does it mean that you should get married, or does it mean you should buy real estate or sell real estate? What does it mean for you? That was judicial astrology. Now, by the time of Copernicus, there was also another branch of astrology, more or less distinct from judicial astrology, and that was called natural astrology. Natural astrology didn't worry so much about what the configuration of the planets meant for you. Natural astrology was concerned with doing calculations to figure out where the planets would be in a year. In other words, given that you knew where they were tonight, where would they be in a year? Where would all the planets be in 2 years? Where would they be, say, even in a couple of weeks, to figure out the future positions of the planets in the sky? That was natural astrology. And the part of astrology that Copernicus was most interested in was natural astrology. He was not particularly interested in judicial astrology. He was interested in natural astrology. And needless to say, it was natural astrology that eventually became astronomy. But if you were to ask Copernicus what he was, he would tell you that he was an astrologer, a natural astrologer. Now, in those days, of course, the telescope had not yet been invented. So you can't say that these amateur astrologers, whatever you want to call them, went out looking through telescopes. What he would spend his time doing after he came home from work and he'd closed the clerk's office, was doing these various calculations, drawing these circles and charts and angles and trying to figure out if this planet moved, and doing very complicated calculations. And I'll show you what they must have been like. He was probably working the old-fashioned way. And he said, look, here is the Earth in the center. He was probably, to begin with, working with the old established method I'll come to his idea later, but he was probably to begin with working with the old method. And he says Jupiter goes around in a circle like this, and so in 1 year it moves 1/12 of the way around. So if it starts here, it ends up here. But then Jupiter itself is is not really here on this circle. What's on this circle is another circle, and Jupiter, this little circle moves around like this, and I have to calculate how far this thing is going to turn in a certain amount of time. And he says, but Jupiter is not really here. There's another little circle here, and Jupiter is really on this little circle, but then there's maybe even another little circle out here, and this circle turns. All of these to make the complicated motion of the planets, all these circles, and he worked out exactly how these things would turn. But besides all of his cranking and his calculating and his working, he also did some basic thinking. And in order to understand his basic thinking, his deeper thinking, I have to tell you something about the planets that everybody knew then, in the days of Copernicus, because it was dark at night and there wasn't television. One of the few entertainments I guess you had was looking at the planets at night. I have to tell you something that everybody knew in the days of Copernicus 500 years ago, but now most people no longer know. People have, in a way, gotten dumber. Of course, a lot of people still know this. But I wanted to tell you something about that. I'm sure you've all seen the planet Venus. Venus is the beautiful planet. It's the brightest thing in the sky. Well, the brightest thing in the sky is the sun. The second brightest thing in the sky is the moon. And what's the third brightest thing in the sky after the sun and the moon? And the airplane landing lights, we'll leave those off. But the brightest natural thing up in the sky after the sun and moon is the planet Venus. Venus is so bright that if you are in the right circumstances, you can see a stick sticking up. You can actually see the shadow cast by Venus. It has to be quite dark, but you can actually see that if you look carefully. In fact, it's the great beauty of Venus, no doubt, that has it named after the god of women, which won't go into that. But anyway, Venus is named after the god of women because of its great beauty. Now, I want to ask you I'm sure you've all seen Venus. When do you see Venus? Well, I'll tell you when you see Venus. And this is the piece of information that was known then but largely forgotten now. You see Venus after the sun sets. The sun sets in the west. And then after sunset, if you look into the west, you see Venus. Not always, but sometimes you see it. And it's pretty low in the sky. And then a few hours after the sun sets, then Venus also sets. Maybe 2 hours, probably at most 3 hours after sunset, Venus is gone. Now, if you don't see Venus after sunset, there's another time when you can see Venus, and that is early in the morning before the sun rises. If you are a newspaper boy who has to get up early in the morning before the sun rises, or if you're a milkman who has to go on a route early before the sun rises, or if you're a Boy Scout out camping and you can't sleep and you get up, you got to go to the bathroom early in the morning before the sun comes up, and you look in the eastern part of the sky, there'll be this very bright star rising. Of course, it's not a star, it's the planet Venus, and it comes up, and then an hour afterwards or 2 hours, probably not more than 3 hours afterwards, after Venus comes up, the sun will come up, and then the sky will become light, and it will be very hard to see Venus. Incidentally, I said hard to see Venus. It's not impossible to see Venus. You can see Venus throughout the day if you know where to look. You just have to know where in the sky to look. And I can proudly say that one day I made it an effort to follow Venus throughout the day. I was in a place where there were trees, and you could always stand by a particular rock and find a tree that Venus was near. And I followed Venus all until 1 o'clock in the afternoon. Without any binoculars or telescope, I could see it with the naked eye by carefully watching where it went in the daylight sky until 1 o'clock in the afternoon. Then I don't know what happened. I got distracted. I could have probably seen it for the rest of the till it went down. Okay. Now, good enough. But I want to ask you a question. Can you ever see Venus at midnight? And the answer is no. Because Venus, if it sets 2 or 3 hours after sunset, it's not yet going to be midnight. And if it rises at most 3 hours before sunrise, sometimes you see it in the morning sky, sometimes in the evening. Can you ever see it both in the evening and the morning? Of course not. It can only be on one side of the sun or the other. But it's always in that part of the sky that is close to the sun. If it were to be in the midnight sky is the part of the sky that's exactly opposite the sun. And it never, ever gets into the midnight sky. No one can see, at least nobody from the United States, can see Venus at midnight. Now, there might be places in the world where you can see. We might come back to that if it's possible to see Venus at midnight from some strange part of the earth. But at least from Europe and the United States and Asia and most of Asia and Africa, you cannot see Venus at midnight. Not only can you not see Venus, there's another planet that even sticks closer to the sun. In fact, it sticks so close to the sun that there are many people, including some amateur astronomers, who have never seen it, and it's the planet Mercury. And it sets, I don't think it even sets an hour behind the sun. At most, probably an hour after sunset, the planet Mercury sets. It always stays very, very close to the sun. It's so close to the sun that it's difficult to see. And sometimes you see the planet Mercury come up in the morning ahead of the sun, but it's a difficult planet to see, being that it's so close to the sun. It's extremely difficult now that people live in cities and have all the obstruction and all the smog and junk down on the horizon. Now, so the planets Mercury and Venus are confined to that part of the sky that's near the sun. Now let's talk about a planet like Jupiter. Can you ever see Jupiter at midnight? Yes. In fact, there's a time almost once a year, almost once every 12 months, there comes at least 1 month out of 12 when you can see Jupiter in the sky at midnight. Can you ever see Jupiter in that part of the sky near the sun? Yes, you can see Jupiter in that part of the sky near the sun. Can you ever see Jupiter in the part of the sky where the sun, in the evening sky near the sun? The answer is yes. Can you ever see Jupiter in the morning sky near the sun? The answer is yes. Of course, at different times it's going to be in different places. Jupiter is free to appear in any part of the sky it wants. And throughout the year, gradually, it will seem to go around and appear in all the different parts of the sky. The same is true of Saturn, and the same is true of Mars. So it turned out in the olden days that there were basically two kinds of planets. One kind of planet could be in the sky any place it wanted to be, like Jupiter, and another kind of planet could only be in that part of the sky near the sun, like Venus. And there was an explanation, an old explanation that had come from the time of Ptolemy as to what caused that. And let me show you the ancient explanation for why there were two kinds of planets. The explanation goes like this. Here is the Earth in the center of the world. And there's the Earth in the center of the world. And going around the Earth was one of the things that went around the Earth was the sun. And here's the sun. And I'll put an S here for the sun. Now, the explanation for why Venus always had to stay someplace in the sky near the sun was this. The ancients imagined that there was an invisible rod, and that rod ran from the sun to the earth. Draw it in there straight. Sun to the earth. And someplace along that rod was an axle, and a wheel was mounted. And here's a wheel. And this wheel turned. And mounted on this wheel was the planet Venus. Now what's the effect of this? Well, this wheel is going to turn. So first Venus is going to appear on one side of the sun, maybe in the morning sky. And then the wheel's going to turn, and Venus is going to appear over here in the evening sky, on the other side of the sun, and then it'll come back, and Venus will alternate back and forth from opposite sides of the sun. But can Venus ever get over into the part of the sky back here? In other words, the sun is here, so this would be the midnight sky as seen from the Earth. No, Venus doesn't have a chance of ever getting back here because Venus is stuck on this wheel, and this wheel is stuck on a rod going through to the sun. It's permanently trapped here. On the other hand, let's take a planet like Jupiter. Jupiter is in an orbit like this, outside here, and Jupiter is free to move. Jupiter is here, and gradually it can move over here, and it will move behind the sun, or in that part of the sky where the sun is, and then Jupiter will be first maybe on the morning side of the sun, and then on the evening side of the sun, and then Jupiter will go around, and its circle will go completely around, and Jupiter can get around even onto the underside of the Earth, onto the midnight side of the Earth, so Jupiter can appear in the completely any place it wants. And these two kind of planets had a name. Jupiter was called a superior planet. And there's two reasons why it might have been called superior. One is because its orbit was above the orbit of the sun. And maybe if it was above the orbit of the sun, that made it superior because it was above. Also, maybe it was superior because it was completely free. And Venus, on the other hand, was called an inferior planet. Why was Venus called an inferior planet? Well, because Venus's orbit was below the orbit of the sun, but also Venus was trapped by the sun. Venus did not have complete freedom to appear in any part of the sky. Venus was always stuck with its little center on this thing that goes up to the sun. So Venus didn't have the freedom that Jupiter had, and Venus was referred to as an inferior planet. Mercury was also an inferior planet. Venus and Mercury were the two inferior planets, and all the other planets, Jupiter, Mars, and Saturn, were superior planets. Okay, now, that was undoubtedly what the view of the world in the time of Copernicus. This is the astronomy that Copernicus must have learned when he was in Rome, or perhaps to use the right words, this was the natural astrology that Copernicus must have learned when he was in Rome. But there is one thing I told you that scientists have a prejudice. Remember, at the end of the talk on levers and on machinery and on what is work, force times distance, I told you that scientists have a prejudice. And their prejudice is this: scientists do not like different explanations for different things. The one thing that delights scientists is to have one explanation that explains many different things. It's like it reminds me of when I studied German, and I learned there were these verbs. I think you had to conjugate verbs. It was so long ago I forgot it. But I learned the rule. I learned how to do the declension or the conjugation or whatever it was. I learned the darn rule. Now it's gone out of my mind. But I took the test, and after the test, the teacher gave me back my paper and marked quite a few things wrong, gave me a bad grade. And I went up to the teacher and I said, "Look, teacher, look, on this conjugation, I followed the rule. I followed the rule." And I still remember what the teacher told me. He said, "Yes, Epstein, you followed the rule, but that was an irregular verb that didn't follow the rule." Well, in science, the idea is that you don't have irregular verbs. Everything should obey one rule. And the thing that Copernicus didn't like about this thing, the thing that must have bothered him so much, was that in this view of the world, there were two basically different kind of planets. Why should there be two basically different kind of planets? And that must have really bothered him a lot. Of course, another thing that must have bothered people, or him, was this rod that went from the sun to the earth. You know, in ancient times, when this scheme was first thought up, in the days of the Greeks, people had not really explored the world completely, or they hadn't explored very much of the world. A great deal of the world was unexplored, and so you could imagine that maybe someplace going down into the equator of the earth, there was a rod from heaven that came down and stuck into the earth. But by the time of Copernicus, people were beginning to explore the world, and the world was no longer quite the strange and mysterious place that it was. It was still strange and mysterious, but it wasn't quite as strange and mysterious as it was. So people must have had a hard time believing this rod stuck into the earth someplace. But I think that aside, the deep thing that bothered Copernicus was that he did not like to think that there was two classes of planets. There should only be one class of planets. There shouldn't be inferior and superior planets, each obeying different laws of motion. And so he got an idea by which he could get rid of this and have only one class of planet. And let me show you what his explanation was to get only one class of planet. This is what he did. He said, well, now, we can account for the motions in the following way. Let's put the sun here, and going around the sun, let's have Mercury, and let's have Venus, and then let's have the Earth going around the sun. And then out here, we'll put Mars and Jupiter and all the rest of the planets. Well, what good does that do? That does the following beautiful piece of good. If this is the Earth, and Venus can be any place it wants to on its orbit. No, now it's not attached by a rod to anything. It can go here, it can go here, it can go here. Because the orbit of Venus is inside the orbit of the Earth, because the orbit of Venus is inside the orbit of the Earth, Venus can never get to the outside part of the orbit of the Earth, so it can never appear in the part of the sky that's opposite the Earth. And if it can never appear in the part of the sky that's opposite the Earth, that's all you want. It can never get into the midnight sky. It's permanently trapped in the part of the sky near the sun because the orbit of Venus is inside of the Earth's orbit. And that was Copernicus's, that was his great insight. And he saw other things too. He saw that if the Earth went around once a year, then there would be times when the Earth would be close to Mars and far from Mars, and that would account for the changing brightness of Mars. And he also had the things go around at various speeds, and the inner things went around faster, so they would pass the outer things, and you could get the effect. You could get the effect that the outer planets. Remember, I told you early on in one of the first lectures that if you follow a planet like Jupiter, it doesn't. If you follow how it looks in the sky, it does not always appear to drift in the same directions through the constellations. Sometimes it stops drifting and it goes backwards, and then it redrifts forward again. And of course, that could be accounted for because the motion of Jupiter in the sky was now due to two motions. One part of the motion was actually because Jupiter was moving through the sky, but there's another part of Jupiter's motion because the Earth is also moving. And just like I can look at you and move my head back and forth, and you seem to move back and forth as I see you. Of course, you're not really moving, but you seem to be moving. So this motion of the Earth could account for the peculiar motion of Jupiter and Mars and whatnot. And so that was Copernicus's idea. Now, I want to tell you a little thing at the very end. Some of Copernicus's friends that were interested in this sort of thing came and asked him. They said, by the way, Copernicus was a smart man. He didn't look for trouble, and they say that he did not publish these ideas, make a complete book out of these ideas, until he was quite old and quite sick, and he knew he was going to die. And they say that in his book, the book that Copernicus wrote, describing how this scheme would work, Copernicus did not see that book in print until he was already in bed getting ready to die. So he, in a way, was a careful man. But he died with his pension from the church. Never got in trouble. Never got himself in trouble. But the story goes that one of his associates asked him, said, Copernicus, do you really believe that it's true that the earth moves? It does seem like such a strange idea to suppose that the earth could move. And the story goes that Copernicus said, look, don't worry about that. He said, if you will just pretend the earth moves, then it makes it easier to visualize why the things in heaven move the way they do, and it makes it easier. It makes it easier to do the calculations. Just pretend. And what he was saying there is this. Just pretend. When you go into a planetarium, well, during World War II, they had to teach a lot of people to navigate fast, both for shipboard navigation and aircraft navigation. They had to teach hundreds and hundreds of people how to do celestial navigation during World War II, and they didn't have time to run them through the long rigmarole. And so the favorite way during World War II to teach people how to do celestial navigation, in part, was to take them into planetariums and teach them in a planetarium where you have the sun, moon, and sky up in there, and teach them how to use a sextant in there. And of course, when you do that, people could say, well, look, in this dome, the sun, moon, and stars aren't like they really are in space. In reality, the sun, moon, and stars are scattered at all different distances in space. In a planetarium, they're all on a dome. But it turns out it makes no difference. You can, if you will pretend that the stars are on a dome, it makes it easier to learn celestial navigation. Why is it easier to learn celestial navigation? Because then if they're on a dome, you can imagine that you can draw lines on that dome, triangles and angles. The dome becomes a thing to draw on, whereas when you have the stars distributed in empty space, there's really nothing to draw on. And so it's by making this pretense, it's easier to think about how celestial navigation works, even though the pretense is not true. And what Copernicus was telling his people, that if they had a hard time believing that the earth really moved, then just to pretend it moved and to do the calculations. And that idea is still used in science. It's still used in science to this day. Scientists are always saying, look, we just follow the equations. Who really knows how the world works? They say, often in quantum mechanics, they say this, all we know is that if you use this equation and you use the equation in the right way, it will work. Maybe there are waves in space, maybe they're not, but the equation works. The equation represents a model of how the thing is. The equation, maybe the equation is right, maybe the equation is not right, maybe it's a coincidence, but the thing worked. This theme is used over and over again in science, to just pretend. Nowadays they use the word, look, this is just a model. And what they mean by a model is, let's just pretend, in the same sense that Copernicus said, let's just pretend. But, and this is an important point I want to get to, in a way, the model has a way, a successful model, after a while, is no longer taken as a model, but is taken as reality. Very important how the idea, when it first appears, is just considered a make-believe model, a make-believe or a model, and then eventually it becomes a reality. You must understand that Copernicus's work had this philosophical byproduct, that he put the earth moving around the sun instead of the sun moving around the earth, and there were the reasons for this. But of course, Copernicus's main interest, was to describe the motions of the planets in the night sky. And you might ask if this would lead to any better description of the motions of the planets in the night sky than the other system where you had the Earth in the center and the planets going around them. And the answer is no. This system would predict the positions of the planets in the sky to a certain degree of accuracy, and the system, the Earth-centered system, would predict with the same degree of accuracy. This system was no better in predicting the positions of the planets in the sky than the previous system. And in fact, in a Zeiss planetarium projector, the planetarium projector has the planets moving around the planetarium sky, and the planets are moved in an old Zeiss projector. They're moved around the sky by a gearwork mechanism. And that, you say, well, what is that gearwork mechanism? That gearwork mechanism in an old Zeiss projector is called a Ptolemaic gear. Why? Because the gearing system is exactly an imitation, not of this Copernican system, not of this Copernican system. It's an imitation of the old Ptolemaic system. And the thing works like this inside of a Zeiss projector. There is a flashlight, effective flashlight mechanism that projects the planet into the sky. And one end of the thing is fixed on something that's called the Earth, and the other end is fixed on a thing called the planet that moves around. And the flashlight that projects the planet is fixed like this. And here's the flashlight mechanism that projects it. And this thing, if this was projecting Jupiter, this end would move around in 12 planetarium years, and the beam projecting Jupiter would move around the planetarium sky in 12 years. But the mechanism in the planetarium is more accurate than that. They even put a correction on the mechanism in the planetarium. They don't have Jupiter here. They probably have another gear out here to make slight corrections. And then this is the Earth pinion, and that's like that. And they put the flashlight here that projects the image of Jupiter. And so the gearing system in a Zeiss projector is not the Copernican system. It's the Ptolemaic system, and it's even named that way on the blueprints of the machine. So you see, Copernicus' system, really its value was not that it made more accurate predictions, but that it was a cleaner way of thinking. But it was not a particularly clean way that you can instrument things. In fact, there's more to this story. There's a bit more to this story about comparing the Copernican system with the Ptolemaic system, and this is the time to tell a story. At the end of World War I in Germany, there were a lot of production workers that made optical parts, gun sights, heaven knows what, but used one heck of a lot of optics in war. Even in World War I, the Germans used a lot of optics, binoculars and whatnot. And these people were all thrown out of work at the end of World War I. And in Germany, they decided to make a make-work project for people, just like they do sometimes in the United States, WPA or Civilian Conservation Corps or whatnot. And in Germany, the first planetariums were constructed for the Deutsches Museum in Munich as specifically a make-work project for optical workers at the end of World War I. And they planned to make 2 planetariums there. One would be called a Copernican planetarium. And the Copernican planetarium at the Deutsches Museum had a big globe in the center, which was the sun, and various railroad tracks and circles, one circle for each planet. And you could actually get in one of these little cars that went on a railroad track, and you would go in a great circle around the sun. And out on the dome, they had a dome with stars on it, and you could see how the sun would move, how the different stars would appear opposite the sun. And of course, you yourself moved around in a railroad car, simulating the motion of the Earth. Or you could ride on the car that was for Jupiter, or maybe on the car that was for Venus, a Copernican planetarium. And the other half of the make-work project at the Deutsches Museum at the end of World War I was to make a Ptolemaic planetarium. And the Ptolemaic planetarium, the people sat down in the center, and the planets and the stars and the sun and the moon went around them. They were all projected on a dome. In fact, it was the first Zeiss projector, like the Zeiss projectors that used to appear in planetariums. And you could first go and see the Copernican system, and you could see the Ptolemaic system. And I imagine there was some thought in the minds of the museum people that the Copernican system would be more popular, because in the Copernican system you'd at least ride around in a railroad car and have a little excitement, whereas in the Ptolemaic system you just sit in your seat and they would project the things going around you. But needless to say, the one that turned out to be most popular with the museum visitors was the Ptolemaic planetarium, and not the Copernican one. And after a while, the Copernican planetarium was torn down and it ceased to exist at the Deutsches Museum. The only thing that remains are photographs of it, but the Ptolemaic, the projection planetarium, was very popular, and they soon made another one for Potsdam and one for Berlin, and then one for New York and one for Chicago, and of course, and one for Philadelphia. And then after a while, the Japanese began to make them, and now there's a planetarium in almost every high school in the world. But that's the story of how they worked. And they worked, but the point is, as far as representing the motions of the planets, they represented them equally well. Now, there's another moral here I want to tell you about. I want to tell you about a few more things. I want to tell you about when new theories come out in science. What causes new theories to come in science? You would think that if there's a revolutionary theory, a revolution in science, like a basic change, like from the Ptolemaic system to the Copernican system, there has to be some huge piece of evidence. So there must be something huge that makes science change its basic point of view. But that's not so at all. Sometimes a very little thing will cause a scientist to change his view. Now, for that scientist, it's not a very little thing. That scientist is living in a different world than most people are. Most people are concerned with their daily life, and life is a struggle. But that one guy, Copernicus, who was not married and did not have a family, and after he came home at night, his interest was doing these calculations, and he noticed that he noticed that difference between the motions of Jupiter and the motions of Venus, that technical difference. Not that it's a technical difference, that one is superior and one is inferior. Most people, if you just told them what's the difference between a superior and an inferior planet, most people would not even know that there are two classes of planets. They wouldn't even, and if you told them there was two classes, they wouldn't know what the distinction was. It's a very small technical thing. But he was living in that world of doing those calculations. And to him, it wasn't a small technical thing. And to him, it was such a big problem that he was willing to throw out the whole idea, the whole Ptolemaic system of the world. He went into a world, essentially, without any physics. Because if you live back in the old Ptolemaic system, that Ptolemaic system fit the physics of the time. After he threw out the Ptolemaic system and he went to this system with the planets moving around the sun, there was no physics to go with it. It was a theory of motion that had no physics. And he was willing to do it because he was just preoccupied with that small technical little difference between superior and inferior planets. The same thing happens over and over again in physics. When, you know, the quantum theory began with a man called Max Planck, and he was concerned with explaining in a mathematical way the colors by which something glows. Perhaps you know that if you take a piece of black iron, and the iron's black to begin with, and then you put it on a stove, and then it first gets cherry, well, no, it doesn't get cherry red first. First it's orange, deep orange, and then it gets brighter, and it gets cherry red, cherry orange, and finally it gets cherry red, and it gets brighter and brighter. Finally the thing almost begins to glow white if you get it hot enough. There was a man called Max Planck, and he was concerned with explaining exactly, not approximately, but exactly why the thing changed color and how it changed color, making an equation to describe how it changes color. Everybody knew that it changed color, but he was concerned with that one little thing. And because he was concerned with that one little thing, he had to overthrow all of classical physics and put in quantum mechanics. It's funny, of course, to him it wasn't a little thing. To Max Planck, the color of that glowing iron was not a little thing. But to the rest of the world going around, it was a little thing. I'll tell you another time when some little thing made a big difference in the world. It turns out that if you have a magnetic coil, if you have a coil of wire and a magnet, and you put the magnet into the coil, you will make some voltage in the coil. In other words, a coil of wire hooked to a voltmeter, and you put a magnet in it, you'll make some voltage. On the other hand, if you take the magnet and hold it still and make the coil move instead of the magnet, it will also make some voltage. In fact, it will make the same voltage. In other words, if you move the magnet into the coil or move the coil into the magnet, and if you move it at the same speed, it makes the same voltage in the coil. Well, most people would kind of agree, yes, that's interesting, so what, of course. But the equations that describe it are slightly different equations. They lead to the same result, but the equations themselves, when you write them down, they look a little different. And Einstein was concerned with the fact that just the equations look different. Everybody knew they led to the same result, but the equations had a different look. And he said, why should the equations look different? Who in the hell would care what the equations look like? You could even stick wire. Somebody who was concerned with electric generators and is concerned with wires and coils, making them, using them, wouldn't even be concerned that the equations look different, as long as they led to the same result. But he was concerned with that little thing, and therefore the whole world got to be changed with the idea of space and time, with the theory of relativity. Well, it turns out that these little things are little keys, but the keys are very subtle, and you have to have an eye, and you have to see them. And it turns out some of the very important clues to how the world works are a little bit hidden, and just they appear to certain people, but they're not obvious. They're not obvious. Okay. Well, so much for that. Now, I'd like to leave you with a question. And again, this question goes back to the pre-Copernican view of the world. And here's the question. The pre-Copernicans, the Ptolemaic view of the world, was that the things in the sky, the sun, the moon, the planets, were in the fiery realm, and that they all glowed. They all had fire within them. They glowed by virtue of fires. Whereas the earth, of course, was an earthy thing, and it did not shine at night. Now, okay, it's obvious that the sun seems to have a fire inside of it, and the stars seem to have light inside of them. Even the planets, pretty obviously, it's as far as we can tell, they're bright things in the sky. Heaven knows why they shine, but they probably shine for the same reason that the sun and the stars shine. They have fires inside them. But there is one more thing up in the sky called the moon. Now, the moon has phases. And it's not too hard to explain the phases of the moon. If you can explain the phases of the moon yourself. You can put a light, not a big house light, but just take one light bulb lamp over in one corner of a room at night. Turn off all the lights in the room. Put the lamp without its lampshade over in one corner. And then put a basketball in your hand and say, basketball, you are the moon. Light, you are the sun. Head, you are the earth. And you can carry that basketball around your head and look at how it's illuminated by the light. And you will indeed see that basketball will go through the phases of the moon. You'll see that there's a crescent phase, and then as you bring it around this way, it will get full. If your head gets in the way, you'll have an eclipse of the moon, but if your head doesn't get in the way, you'll have a full basketball or full moon. You can see the phases of the moon, and you can explain them that way. Incidentally, it's easy to do it that way, but a lot of people can't explain the phases of the moon. At San Francisco City College, they actually go through the trouble of asking people that are trying to get a job teaching physics to explain the phases of the moon. That's their favorite question. And many of the people who want to become physics teachers, who have studied physics, and want to be a physics teacher at a college cannot explain the phases of the moon. That's a fact. More than half of the people who want to become a science teacher a college science teacher cannot explain the phases of the moon. But that idea of explaining the phases of the moon was something that was known. It was known even to the Greeks. It was known before the Greeks, just this explanation I gave you. But now, I want to come to the point. It's pretty obvious then that the source of the light on the moon, the thing that's responsible for the moon's light, is not the moon itself, but the sun. Because remember, it's the sun that causes this basketball to have its phases. So the moon, you could say, does not have a light inside of itself. It's up in the fiery sphere, but it is itself not on fire. It's shining not by fiery light within itself, it's shining by reflected light. So there is an example that maybe it's an earthy thing that doesn't have light, and it's up there in heaven, so it's a clue. Now, how would the ancient people were aware of this, and this argument was made many times to the ancient people that they must have thought about this. The moon, maybe it's not a fiery object. What's it being up there with the other fiery objects for if it is not a fiery object? How did the people explain this? Well, what is the way out of this? They had a way out of this, and you might think of the way out of it. You might think of how the moon looks. Of course, if the moon were always a full moon, then you could say it had a fire within it, couldn't it, if it was always full? But what about when the moon is a crescent? You might think of how the moon looks when it's a crescent. In fact, if you see a crescent moon, you might look at it very carefully and think about if there possibly could be a fire within it. Now, if you look at it from the city is so bright that it's hard to see what I'm talking about. But take a time when most of the moon seems to be dark, when it's a crescent moon, and look at it from someplace way out in the country where it's very dark, and see if there might possibly be a fire within the moon, as there should be, of course, according to the pre-Copernican theory of the world. There should be a fire within it. See if you see any hints of a fire within it. Now, I'll tell you a little story about that when next we meet.